Good morning, good afternoon, or good evening. This is going to be a full paper work through of the November 2022H paper. This is as close as possible to a blind work through. I will probably have seen some of these questions before, but I haven't prepared anything, hopefully in order to give you my first impressions and my thought processes as we go through this paper. As always, have a read of the front while you're waiting for your examiner to say go. Remind yourself of the rules and let's start. Page 2 is always our formula page. Worth having a look at this really closely, working out exactly what you are given and what you need to learn otherwise. And we're into the questions. We've got 21 questions on this paper, and our first is our simple algebra, in particular indices. Remembering our rules: when we multiply, we add the powers; when we divide, we subtract the powers. This one is a very commonly misdone question. The number is going to act the same, so it's still going to be 3 squared, not 6. A lot of people like putting 6 there. 3 squared, we square the c, and then power to a power means we multiply the powers to get d to the 8. Solving an inequality: most of the time inequalities are exactly the same as solving equations. So we are going to subtract 7 from both sides and divide by 4. If you remember, the only difference is if you have a times or divide by a negative, and then you flip the inequality sign. We did not have that here, so we are fine. Question 1 done. Question 2. Table shows information at its time in minutes of 120 customers. That might be important later. And we have our group frequency table. We want to find the modal class. Which class is the most common? Well, this one here has the highest frequency, so our modal class is 50 to 60. Don't put 40. 40 was the frequency. That's how often the modal class appeared. The class itself is 50 to 60. Work out an estimate for the mean length of time spent by the 120 customers. Well, that means I need a couple of extra columns. I need a column for the midpoint because we are grouped, and I need a column for f times midpoint. So the midpoints are just the middle of our classes, and for these questions they're often quite symmetric. They follow a nice pattern. F times midpoint, I grab my calculator and I start doing some multiplications. 6 times 25 for the first one gives us 150. 26 times 35, 31 times 45, 40 times 55, 65 times 17. As I'm doing those calculations, I'm also thinking, what type of answer am I expecting? If I look at my data, I'm expecting my answer to probably be around 40 to 60 range. That's where most of my data is. I now need to add up the f times midpoint column to find the absolute total of these 120 different times. So I get 5,760. So then the mean is that total. A lot of people do divide that by 5, which is the number of classes. Divided by 5 will give you something over 1,000, which is completely unreasonable. But divided by the actual total gives my answer of 48, which, as I guessed at, is exactly where I'd expect the answer to be. Sorted. Question 3. An angles question. We have a parallelogram ABCD, an isosceles triangle DEF, where we've got our two base angles are equal. We have a couple of straight lines. An angle BCD is 58. We want to find an angle DEF. So there's a lot of things to think about here. We've got our rules of angles in triangles, but we've also got rules of angles in parallel lines, being a parallelogram. So this angle here because that and that are parallel, well, this is forming a C shape. So that's angle CDA is 180 minus 58 is 122. As co-interior, you can't say because C shape, we have to use the proper wording, because as co-interior angles sum to 180. Okay, well that's a really useful angle because that's how I can translate to the triangle. So now angle EDF is also 122 as vertically opposite angles are equal. So we also have that 122 in there. And now finally we've got our isosceles triangle. So what's that? DEF is half of the leftover angle from that triangle. So half of 180 minus 122, half of 58, so that's an angle of 29. And I've used two rules there as base angles in an isosceles are equal and angles in a triangle sum to 180. Quite a lot of writing for a question like that, but notice it was also worth 5 marks. So getting all those reasons aren't particularly challenging, but do just give you that extra credit all the way through. We have a wordy question with ratio next. Andreas, Isa and Paolo share some money in that ratio. The total amount that they receive is 76 more than the amount that Andreas receives. So we have 2 parts there, 5 parts there, and 3 parts there. So we're saying how much more. Well, that's saying that the 7 parts is £76 more than 3 parts. So the difference in the number of parts is 4 parts, and we've been told that that is actually £76. Well, that can work out what 1 part is. I haven't even read the rest of the question yet, but I'm going to work out what 1 part is in preparation. 1 part, therefore, is £19. Reading the next question, Andreas buys a video game for £46.50. Work out how much money Andreas has left from his share. Okay, so let's work out, now that I know what 1 part is, how much Andreas gets. Well, he gets 3 parts. He gets 3 lots of that 19. So he gets £57. But he spent £48.50. So he has left the result of that subtraction. 57 minus 48.50 comes out as £8.50 left. Double check I haven't misread anything from the question. I've used the ratios to find out what 4 parts were. I found that with 1 part. I then found out Andreas's and how much he has left. That seems reasonable. He got 57 and he spent about 50. £8.50 left. Question 5. We have annual salary of that much. He gets a salary increase. Increase, we start with 100%, add on the percentage and divide by 100, so that multiplier is 1.04. So the calculation I'm going to write into my calculator, which I'm writing down for the sake of the examiner for that method mark, is 3,130,000 times 1.04, which comes out at 3,255,200 Japanese yen. We have someone buying a car as well. The value of the car when it was bought was that, and it depreciates by 15%. Well, that's now going down, so we start with 100%, we lose 15% and then divide by 100. We get down to 85% or 0.85. We want to know the value after 3 years. So using our compound interest formula, the initial times the multiplier to the power of the number of years. Again, I'm writing that down purely to get my method marks from the examiner. And typing that exact calculation into my calculator is 460,593.75. The question wanted it to the nearest Japanese yen, so it's 460,594. Good habit is to separate your digits just slightly. I maybe separated them a bit too much there into groups of 3. Question 6. Find the equation of that line. Equation of a line, y equals mx plus c. We need to know 2 pieces of information. We need to find the plus c, which is fairly easy. That's where we cross the y-axis. So that's my c. And I also need to find the m. Well, there I'm going to draw myself a right angled triangle to do my change in y, which is 3, over my change in x, which is 1. So my m is 3 over 1. I'm going to double check that is an uphill line, so that is intended to be positive. So my curve is y equals 3x minus 2. Question 7. Immediately this is shouting trig to me, SOHCAHTOA. Find the value of x. Nothing fancy going on here. Let's try and use our SOHCAHTOA. Let's label our sides. There's our opposite to the angle x. There's our adjacent to the angle x. I'm not going to label my hypotenuse because I don't care about it. So therefore we're using tan. So tan x equals opposite over adjacent. That's 3.4 over 4.7. So x is tan inverse of that thing. I could work that fraction out and write down some decimal places, but there's not really any point. Might as well leave it exact for as long as possible. That comes out 35.882, etc. Check what they want us to round to. They want the answer given to 1 decimal place, so 35.9. Quite a nice gift of a question as we come to the middle of the first half of the paper. Work out the area of this isosceles triangle. 2 ways to do this question, depending whether or not you like half AB sine C or not. We could either try and find this angle here. It looks like we're going to have to. We're going to have an angle somewhere, either to use half AB sine C or to find the height of this triangle once we split it in half. I'm going to split it in half anyway, because if I split it down the middle here, stick a right angle down there, this side is now 4 centimeters. I don't need to worry so much about anything else. And indeed, I don't need any angle work now, because now I can use Pythagoras to find the height. The reason I could put that as 4 was because of that isosceles nature, the fact it's symmetric about that middle line. So let's use Pythagoras instead. Let's call this h. So Pythagoras says h squared plus 4 squared equals 8.5 squared. So h squared equals, that squared comes out 72.25. Subtract off the 4 squared. So h squared is 56.25. And therefore the height is the square root of that. Comes out nicely. Not always, very unlikely that happens, but it comes out nicely as 7.5, and therefore the area of my whole shape is a half base times height. Well, now my base is the whole 8. I'm going to do the whole shape in one go, times by the height of 7.5. That comes out at 30. Stick some units on, and happy days. Question 9. Diagram shows a solid cylinder with a radius. I notice already that the picture doesn't have a height labelled. The question doesn't ask me for the height, but pretty much anything that I need to do with a cylinder, I'm going to need this height, so I'm going to label it on straight away. I have, however, been told the volume. That feels like I need to go backwards to find the height. And then eventually I'm going to find the surface area. Okay, so let's use the volume first. So the volume, you can look back at the front, is pi r squared h, and that equals 72 pi. Pi is on both sides, let's cancel the pi's out, let's put in r. R was 3, so r squared is 9, so 9h equals 72, so h equals 8. I now know everything I need to about this cylinder, and I can find the surface area. Now the surface area, they have put in bold, they want the total, not just the curved. So total surface area is 2 circles for the top and bottom, plus that curved surface, which again is at the front of your formula booklet, is at the front of your paper on that formula sheet, is 2 pi r h. Don't need to memorize that, that is given to you. Let's put in all the numbers, that's 2 pi times 3 squared plus 2 pi times 3 times the 8 we've just worked out. Now I have realized that the question does want this as 3 sig fig, but I'm going to work out in terms of pi first, just by not typing the pi into my calculator, just doing the numbers. We had 18 plus 48 pi's, and now I'm going to times that by pi and give it to 3 significant figures. Again, for the sake of the examiner, I write out a few more first before rounding it. Check the units, it's in meters, it's an area, so meters squared. Question 10. Cumulative frequency. Okay, so we get 1 mark just by remembering cumulative frequency is a running total. It's an add up as you go along. So 0 to 10 is just 10. 0 to 20 is the first 2 parts, so I need to add on 16, I need to add on 44, add on 29, add on 15, 114, and then add on 6. Check that my total matches their total, and I'm happy. And now I presume I'm going to have to sketch one. I am. It's going to be a bit jarring as I flip forwards and backwards across these 2 pages, I do apologise. But we're plotting the cumulative frequency against the endpoint. So we're plotting these 2 things against each other. So the first one is 10 at 10. I can start at 0, 0. You won't get marked up or down for my sign at 0, 0, it just makes it look nicer. 20 goes to 26, which is there. 30 is at 70. 30 is at 70. 40 was at 99. Now these are going up in 2s, so you need to be a little bit careful. That doesn't quite hit the 100. At 50 it was 114 if I remembered correctly. That's not 114, so 110 is there. So I need to go 2 little bars above that. So there's my 114, and finally there are 160 people in total, so it goes up there. Now with your pencil you'll be able to join this on paper a lot nicer. Oh, and as you can see on the tablet it's not quite smooth. I'm going to do that again because I'm going to need a nice smooth curve in that area for the next part of the question. That looks like a nice cumulative frequency graph, exactly the type of shape that we expect. Use your graph to estimate the interquartile range. So we need to find the lower quartile and the upper quartile and find the difference. We have 120, a quarter of that is down at 30, so my lower quartile is going to be living along this 30 point, and you should actually draw these lines on your graph because this is your working. These are your working lines. So my lower quartile is 21. My upper quartile is 3/4 of the data. 3/4 of 120 is 90. So my upper quartile is going to be living up there. Again, draw the lines on your picture. The examiner will be looking for them to confirm or deny your working. Upper quartile minus lower quartile gives you the interquartile range of 15. You always get a bit of a range for that because, of course, as you can see my picture, everyone's graphs will probably curve slightly differently. So you do get a range which is all the more important why you need to show those working lines on your picture. Part D. Use your graph to find an estimate for the number of buses that were more than 48 minutes late. The more than is important here because commuter frequencies only ever deal with less thans. So let's first work out how many are less than 48. So I need to find my 48 down here. I need to go up. And of course you're using a ruler for this. Trying to keep it relatively accurate. And then I'm going to go across. And I'm going to read that off. Well, that bit there was 110, so that looks like 112. So less than 48, or 112. We wanted more than 48, so we wanted the opposite side, 120 in total, so that means there are 8 which are longer than 48 minutes. Again, that seems reasonable. We knew that from 50 to 60, there were 6 buses. So from 48 to 60, being a little bit more than 6 makes a lot of sense. Question 11. Some more index laws. This time we've got some fractional powers. Again, you could try and do these properly. The question hasn't said to do anything too fancy, so I'm just going to type stuff into my calculator. For the number in front, that's giving me 8 to the power of 2/3. So I'm going to start with a 4, and then I can just multiply the powers for, because power to a power is a multiply, e to the 10. Part B, express that in that form where a and n are integers, are whole numbers. Okay, well, first thing I want to deal with is that negative. So the negative power is flipping the fraction over. Okay, but that doesn't look like the form they want. They didn't have it as a fraction, so I'm going to put that y as a power of -1, bring it out of the fraction as a power of -1, and then finally do the power 4. The y's are easy, power to a power, multiply the powers. The 2, however, gets hit to the power of 4. 2 times 2 times 2 times 2 gives us 16 in front. Maybe a bit of an awkward question, that one. Not particularly pleasant. Part C. As soon as I see any of these solve equation questions, I always think to myself, what don't I like? And I don't like those fractions. They are getting in the way and they're preventing me from doing the simplifying that I want. So I'm going to try and remove those fractions as quickly as possible. Best way to do that is I'm going to multiply through by 12, 12 being the lowest common multiple of 3 and 4. Now when I multiply by 12, I need to multiply each separate part. So multiplying that first fraction by 12, we're multiplying by 12, but we're dividing by 3, so really we're only multiplying by 4. The 3 cancels with the 12 to leave the 4 behind. Now in exactly the same way, we can do the second fraction. We're multiplying by 12, but we're dividing by 4. The 4 cancels out, it leaves behind a 3. And finally, on the right-hand side, 6 times 12 gives us 72. Now I don't like the brackets, so I'm going to deal with the brackets. Let's expand those out. 16x minus 8 for the first one, nice and easy. The second one you need to be careful, because it's a whole -3 on the outside. So -3 times 5 gives us a -15, but then it's -3 times -3x. That's a positive 9x equals 72. Time to simplify. I'm going to collect like terms on the left. It's got -23. Not particularly happy with this, but I'm not particularly happy because it doesn't look like it's going to give me a whole number. No reason why it shouldn't, but it's always nice when it does. Adding the 23 to both sides, and finally dividing by 25, we get 3.8. Now, because that's not a nice number, I have got my doubts. I am unsure whether that is correct or not. So what I'm going to do before I move to the next question, is to retype it into this side of the equation to see if it does or does not give my answer of 6. If it does, I know I've got the question right. If it doesn't, I need to go back and check. I've typed that in and it does indeed come out as 6. I know I've got that question right. I haven't made any silly mistakes along the line. A very good habit to be in, because if you're checking your work as you do it, it's much easier to find mistakes rather than coming back to it later. Given that 3 to the x over 9 to the 3x equals 81, find the value of x. These kind of index power equations, best way to tackle them is to turn everything to the same base number. The base number that works here is 3. So I'm going to notice that 9 is 3 squared and 81 is 3 to the power 4. Putting that into the equation, 3 to the x now over 3 squared to the 3x equals 3 to the 4. And I'm going to continue to simplify that left hand side. 3 to the x, power to a power, we multiply the powers, so 6x equals 3 to the 4. And of course I was putting an x there, 3 to the 4. And then dividing powers, we subtract them, so it's negative 5x equals 3 to the 4. Base numbers are the same, both sides look identical, so the powers have to match. And finally, x equals, dividing through by negative 5, negative 4 over 5. Once again, I am going to type this into my calculator just to see if I've done it right. 3 to the power of negative 4 over 5 over 9 to the power of 3 times negative 4 over 5 does indeed give me 81 once again. So I know I've got that question right. Question 13, use algebra to show that. Now you could try and be clever and just type into your calculator, you'll get no marks for that. The algebra technique that we use is as follows. We're going to let x equal that thing, and my habit is I write out the decimal a few times rather than the recurring dots. It allows me to see what I need to cancel a bit better. Technique is to move that decimal place so that the repeating part is in front of the decimal place. Well, I need to move that decimal place 3 spots, so I'm going to times it by 1,000. That gets me to 681.8181, etc. Well, I want to subtract something to kill off all of those decimals. Now I can't subtract x because the decimal places don't line up, but I can subtract 10x. If I put 10x underneath, it moves the decimal place 1 spot, and you'll notice all the 8 ones line up perfectly. So now when I subtract these two things, 990x on the left, subtracting them, all the decimal places cancel, and I'm left with 681 subtract 6, 675. Now it's just a case of simplifying this. X equals 675 over 990. Now most mark schemes allow you to have that as your penultimate stage of working and put that equal to 15 over 22. I'm going to actually simplify it a little bit slower. I notice there's a common factor of 5, so I'm going to simplify to 135, and 990 divided by 5 gives me 198. I'm going to put a little divide by 5. I'm really showing the examiner there is no cheating going on here whatsoever. Now the next common factor is a little harder to spot. If you know about your divisibility rules, you'll notice that they are both divisible by 9. So I'm going to divide top and bottom by 9. And that does actually get me to exactly what I wanted, and I'm done. Once again, you could probably, most mark schemes do allow you to go from the 675 over 990 straight to the 15 over 22 by typing it into your calculator. You don't need to do those simplifying steps mentally. Question 14, a set theory question. We're now past that halfway point. We're getting to the questions which are a little bit more challenging. Okay, set theory. So our universal set is all the numbers between 10 and 25. They're the only ones we're allowed to think about. A is those that are less than 18. B are between 13 inclusive and 22 exclusive. So n of A is how many elements in A. Well, A is 10, 11, 12, all the way up to 17, we're not allowed to have 20. Now that isn't the answer, it wanted to know how many. That is 8 elements, 10, 11, 12, 13, 14, 15, 16, 17. Yes, I did count that up on my fingers. Nothing wrong with that. Now we're going to list the members of A union B dash. So that's saying, well, A union B is all the stuff which is in A or is in B. Well, in words, A union B is the stuff from 13 all the way up. Oh no, I can go even lower because A allows me to go lower. So I can have all the way down to the bottom value, which is 10, all the way up to, well, A goes up to 17, but B goes up to 21. So A union B is that set. But I've still got that little dash. Now the dash means not. So we're looking for the things which are not in that set, but remember we're only allowed to be between 10 and 25 anyway. So those elements are 22, 23, 24, and 25. Everything else is in one of those two sets. List the members of the set A dash and B. So that's the stuff which is not in A. So not in A is the stuff which is bigger than or equal to 18, and we have to be between 13 and 22. So which numbers are bigger than 18, bigger than or equal to 18, and smaller than 22? Well, 18 is 19, 20, and 21. Those are not in A, and they are in B. And finally, we have C. Oh, so this is an uncommonly used notation. So this is a subset. So this is saying that C is contained within A and contained within B. So it has to obey the rules of A and obey the rules of whichever the other one I didn't just say was. And there are 5 elements. So how many elements are actually in both? Well, 13 is within both. 14, 15, 16 and 17 obey both A's rules and B's rules, and there's 5 of them, so that has to be the set C. There are no other choices. Question 14 is done. Question 15. Make X the subject of Y equals that. Well, we need to try and get X on its own, and if you remember, this question has a very rigid set of steps. First thing we're going to do is get rid of the fraction. Just like we're solving equations, I don't like fraction, so I get rid of it. I now don't like brackets, so I get rid of them. Expanding out the brackets on the left, as so. And now comes the one weird step. We want X to be subject, so we need to put all the X things on the same side and all the things without an X on the other. So I'm going to add 2x to both sides, and I'm also going to subtract 3y at the same time. My left now becomes xy plus the 2x, the 3y's gone, and on the other side 5 minus 3y, the minus 2x is gone. And now I'm going to undo those simplifying steps I had at the beginning. I'm going to refactorize. I'm going to put things back into brackets. So I have my common factor of x, and now x only appears in one place. That allows me to undo the layers much more easily. So I'm going to undo that final layer by dividing by that bracket. Now x is the subject of that equation, and we are done. Question 16. A nasty set of simultaneous equations. This is a quadratic set. Now for the quadratic set, you can't use the elimination method. You can't multiply one of them by something and the other by something and hope that they cancel. You need to substitute. So I'm going to call my, as I normally do, give them some names. I'm going to rearrange equation 2, the linear equation, to make it x equals. That allows me to make the substitution. And then I'm going to sub into equation 1. So this is 3 lots of Instead of writing x now, I'm writing 2y plus 1 minus y squared equals 8. Well, this is now an equation with only one letter. This I can solve. Expanding out those brackets, I'm times everything by 3y. 6y squared plus 3y minus y squared equals 8. I've noticed this is turning into a quadratic. Quadratics, I want everything to be on one side. I want it to be equal to 0. Success. Now I could try and factorize this. I can try and complete the, not complete the square, that's, you can do it, but I wouldn't advise it. Or I could use formula. I prefer factorizing, and this does factorize fairly nicely. Requires a bit of thought, but we get our 5y squared with that combination. We have a negative 5y and a plus 8y to make the plus 3y and the negative 8 on the end. Probably sensible unless you've really practiced factorizing. Best way to probably tackle that part of the question is with the formula. I get my two answers, y equals negative 8 over 5 and 1. Well, I still need to go find my x values, so I'm going to use the equation 2 again, which said that x was 2y plus 1 to get my two extra values. I'm going to do the one I can do in my head first. When y is 1, x is 3, and the other one, 2 lots of negative 8 over 5 plus 1 gives me my other x values of negative 11 over 5. And therefore, I'm going to put my answers down on the outside. I'm hoping it's got the space. No, it doesn't. So I'm going to say x is 11 over 5, y is negative 8 over 5, or x equals 3, y equals 1. Once again, with simultaneous equations, it's worth checking them back in the original. So I'm going to do exactly that before I move on. I've already used equation 2 to find the values of x, so I'm going to use equation 1. So I'm going to try and sub into equation 1 up there the different values. I'm going to do the hard one first. 3 lots of negative 11 over 5 times by negative 8 over 5. Subtract, put it in a bracket. Otherwise your calculator will square it wrong. The negative 8 over 5 squared. Double check that I've written everything correctly. Equals, and that does equal 8. So that solution worked. The other one, 3 times 3 times 1, subtract 1 squared, also gives me 8. Brilliant. So those two solutions are correct. They have to be correct. There's no other options. Question 16 done. Question 17. Diagram shows a rectangle. The area of the rectangle is, given that the area is less than that, find the range of possible values for x. This is a nasty question because it doesn't really look like there's enough information. It also really doesn't show you what type of question this is till right at the end. Let's do the only sensible things available to us. Let's work out the area of this rectangle. Area of a rectangle is base times height, so let's do exactly that. Let's take the base and let's take the height, let's multiply them together. Let's simplify by expanding them out. We get 6x squared minus 12x plus 4x minus 8. Simplify further. And we have the areas given as so. But we were told that that area was less than 3x plus 27. So let's put it less than that. Well, now we can finally see what the question's actually about. This is a quadratic inequality. Quadratics, we know we should rearrange to make them, to compare them to 0. Now I'm going to take a quick moment to see if that does factorize or not. It feels like it could, but both 6 and 35 are very difficult to consider all of their options. So I'm not even going to bother trying to factorize that. I'm going to use the formula to try and find my two critical values, my two roots. My formula is negative b plus or minus the square root of b squared. Again, put that b in the bracket because otherwise your negative numbers will go poorly. Minus 4ac all over 2a. Once again, I'm writing that out, although I'm going to type it into my calculator anyway. I'm writing that out for the examiner's benefit. And I'm going to very carefully type all of that into my calculator, make sure I put the brackets in the right places. One of the values comes out as 7/2, with the positive, and the negative comes out as -5/3. Now that tells me immediately that this did factorise, because those numbers are, well, they're not nice, but they're exact. They don't have any certs in. Well, now, thinking about the quadratic inequality method, we need to think about the graph. So we have a positive quadratic that has two roots at -5/3 and 7/2, and we've been told that this quadratic is less than 0, which means it's below the axis. So where is this quadratic below the axis? It's between those two values. So my answer is going to be the sandwich inequality between 5/3 and -5/3 and 7/2. Notice I use strict inequalities because the question used strict inequalities. 5-mark question, quite generous, but a lot of work and a lot of care needed for that question. Question 18, another shape question. We have a cuboid, we have various lengths labelled on for us, and we have an angle. Okay, that's unusual. Not often do they give you an angle instead of giving you the side lengths. We want the volume. Well, in order to find the volume, I need to find the final side length, the side length BC. If I know that, I just multiply that by the 4 and the 5 and I'm sorted. So I need to somehow unpick this first 35-degree angle. The most important thing to first notice is where it is. It's the angle between CH, I've already drawn that in, and the base. But when you have the angle between CH and the base, you need to drop down a perfectly vertical triangle. In this case, that's by dropping it down to A. So that angle there is my 35. And I'm actually going to draw that triangle outside of the picture so I can visualize it better. I have my triangle AHC. Angle down there is the 35. The height there is the 4. So I want, well, if I can find AC, I can use another triangle to find BC afterwards. So I want to try and find this down here. So I'm going to call that X for now. This, again, is a SOHCAHTOA question. That's my opposite. That's my adjacent. So we're talking about tan. Tan 35 is the opposite over the adjacent, 4 over X. The trick to simplify those ones is just by swapping the fraction round. Officially we're multiplying by X and then dividing by tan. So X is 4 over tan 35, which my calculator gives me as a syntax error because I didn't close the bracket. Gives me out as 5.712, etc. Now be careful, don't round that number too early. Don't try and just use 5.7 later because there's a chance you'll get the answer wrong to that many decimal places. I'm going to continue to use the answer button in my calculator to store the exact value of that. Well, that's now my side AC. Well, looking back at my picture, I now have that side there is 5.71, etc. So now the useful triangle is the triangle ABC. Remember, our aim was to find that BC side. We have that side is the 5.71 that we've just worked out. This side is 5. Let's call this side Y for now. It's a Pythagoras. We don't care about the angles. We have a right angle there. So it's saying that 5 squared plus Y squared equals that 5.71, etc. squared. So Y squared is that thing squared minus 25. So my calculator, I still had that answer available. I haven't turned the calculator off since. So I'm going to type in answer squared minus the 5 squared. Give me 7.633, etc. Square rooting that to get the actual side length. So we 2.7629, etc. Again, I'm not going to round early. I'm going to keep that as my stored answer. So why did we do that? We did that to find that side length BC. That's now my 2.76. I did that because I wanted the volume. Well, volume is base times height times width, 4 times 5 times this newly found value. And again, I'm going to type into my calculator 4 times 5 times the answer, because the answer is still stored there as that 2.76 exactly. So now it's 55.258, etc. So to three significant figures that the question asked for, 55.3 centimeters cubed. Now you can kind of see the risk there. The calculator came out as 0.25. If you rounded early, if you rounded anything down too much, you might have been getting 0.24, and you would have got the wrong answer there. You would have got 55.2, not 55.3, just because of early rounding. So be very careful with your rounding. Question 18, done. Another big 5 marker. We've got quite a lot of 5 markers on this paper. Question 19, a vectors question. Now they haven't drawn a picture, which is quite saddening, but let's draw it ourselves. We have OAB is a triangle, so let's have some origin here. OA, put A up there, let's put B down there. We have that vector there, we're calling A, that vector there, we're calling B. The point C lies on OA such that OC to CA is in the ratio of 1 to 2. So there's some C here, so this is in a ratio of 1 to 2. D is on OB, so the OD to BD, DB, is 1 to 2 as well. So we've got some D on here in the ratio of 1 to 2. Using a vector method, prove that A, B, D, C is a trapezium. Okay. Well, what's it mean to be a trapezium? To be a trapezium means you have exactly one pair of parallel sides. Well, it's quite clear from the picture that we've now drawn that AB and CD are the 2 parallel sides. So actually, to prove that, we want to show AB is parallel to CD. The method to do that is to work out both of these vectors and show that one is a multiple of the other. AB seems easier. Let's try and work out AB first. If I'm going from A to B, I need to go backwards to the origin, negative A, and then forwards there. So AB is negative A plus B, or B minus A. C to D is going to be a lot harder. A couple of things we can say straight away. Well, O to C is a third, because of the ratio, of O to A. It's 1 part out of the total 3 parts. Well, that means it's just a third little a. OD, well, that's exactly the same ratio. It's a third of OB, so that's a third of B. Well, now we can do the same trick we had before. C to D, we need to go backwards along C, forwards along OD, and we get negative a third A plus a third B. Well, now we need to remember what it means for vectors to be parallel. That just means that one is a multiple of the other. So if I factorise out that third, well, that's exactly saying that C to D is a third of A to B. i.e. CD is a multiple of AB, which is exactly saying that CD is parallel to AB. Well, that means you found a pair of sides which are parallel, and that's exactly what you need to be a trapezium. So ABDC is a trapezium. Notice I haven't skipped any steps. I'm putting my conclusion quite wordy because it's a proof question. Put my little box to signify I am done, and that is my 3 marks for a vector proof. Not an easy question, however obvious it may look once you've seen the solution. A really challenging question, these proof questions. Question 20, we're coming right near the end now. Question 20, a bag contains X counters. Already putting some fear. This is probably going to be some weird probability equation. There are only red and blue in the bag, that's nice. There are 4 more blue than red. Okay. We take 2 counters at random. The probability it takes 2 blue is 3/8. Work out the value of X. Well, this does seem quite challenging. So let's try and work out what we can. So let's say there are R red counters. Let's start with that. We can also say there are B blue, but we'll get rid of that quite quickly. So there are 4 more blue than red. Well, now I can say that if we have R red, there are 4 more blue, so that's R plus 4. And that also tells us that this X was the total number is 2R plus 4 if I add those two together. So I'm in a position where I can rearrange to make R equals and try and solve the equation for X. I'm actually going to solve the equation for R and then go back to X at the end. That's going to be slightly easier. Now the probability statement we've given is the probability of 2 blue is 3 out of 8. Well, how could I have picked 2 blue? I had to pick a blue first. Well, the first blue is going to be R plus 4 over X, but I'm going to use 2R plus 4 instead, keep everything in terms of R. But that was our first blue counter. And we need to pick the second blue counter. But there's 1 less counter now, so now it's only R plus 3 blue counters in a total of 2R plus 3. If I'm taking 2 things out, I'm not replacing the first one. I can't pick the same counter twice, so it is a without replacement style question. Now that looks horrible, but that's the equation we have to try and solve. I don't like fractions. If I can help it, I don't like having fractions in my equations. So I'm going to multiply up by all of the denominators. On this side, I gain the denominators of the other side. I'm always writing an X there where I wanted to write an R. So I've gained the denominators there, and I'm also going to multiply up by the 8 on the other side. So kind of a cross multiplying style thing. We lose the denominators on the left, appears on the right, lose the denominators on the right, they appear on the left. And I'm looking at that and I'm thinking quadratics again. This is going to be another huge quadratic question, which isn't surprising. We took 2 counters out, that's giving our double level. So I'm going to expand everything out carefully. I'm going to expand out the quadratic bits first. We get 4R squared, we've got an 8R and another 6R, that's 14R. We've got 3 times 4 on the end. Over here we've got 8R squared plus 4R plus 3R plus 12 again, expanding the next level of brackets. 3 times 14 is 42 plus 36 equals, just checking my mental times tables. Quadratics we want to make equal to 0, so let's move everything to the left hand side. 42 subtract 56 is a negative 14. And then negative 60. I am going to check those 2 calculations. It'll be unfortunate to make a mistake this late into the paper just because you're not checking. That quadratic we need to try and solve. I have noticed, however, that there is a common factor, so I'm going to divide through by 2 to make my life a little bit easier. Now, can I factorise that without too much bother? I think I can. I've noticed that I can get the 7 from 12 and 5. Well, I can get the 12 from 2r times 6 and the 5 from 5 times 1. 2r I need to make negative 12 and positive there. Once again, if you're not 100% comfortable with factorising, because that is not an easy factorisation to do quickly, use the formula or use split the middle method. That gives me two solutions, r equals negative 5 over 2 or r equals 6. Thinking about the context of the question, this r we introduced as the number of red counters. So can I have a negative 2.5 red counters? Well, no. So that solution is not valid. So we have 6 red, we have 4 more, so you've got 10 blue, which means this x that the question introduced was the total number of counters is 16. Of course, I could have got that from 2 times r plus 4 as well, from that bit that we mentioned near the beginning. A lot of subtleties with that question. Probably the most is noticing that you should use a different letter to make your equation. You could have made your equation with this capital X. It would have worked. It would not have been as nice. It would have been a lot less pleasant. And even that wasn't very pleasant to start with. Question 21. We see the end of the paper is there. We have our total marks written at the bottom. So, final question, let's get it done. The function f is given that. Express that in that form. That's to complete the square. It's not the nastiest, but it is fairly unpleasant because of the negative in front of the x squared. Whenever you have anything in front of the x squared, the technique is to factorise it out. So I'm going to factorise out the negative sign, or officially factorise out a minus 1. Now I like to use big square brackets here to focus my attention. Once I've got my big square brackets, I can then complete the square inside there, as I normally do. Half the number in front of the x, put that inside the bracket, squared. Subtract off the square of the number inside the bracket, so we're subtracting off that 3 squared to get minus 9 in there. Carefully re-expanding out those brackets, we got the minus thing squared, but then we've got a minus minus 9, becoming a positive 9, giving my answer as 14 minus. And checking that does match the form that they wanted. Yes, P is 14, Q is 3. Using your answer to part A, find the range of values for which the inverse function is positive. Wow, okay. So let's think about the inverse function first. So let's try and create it, what I mean there. So let's set y equals 14 minus x minus 3 squared. Let's try and simplify that. So we're going to add on that bracket squared, subtract off the y. We're not going to re-expand the brackets. This is the kind of one of the big benefits of complete the square is x only appears once, so you can undo the layers. Now officially I have a plus or minus here, but we've been told that x is less than 3, which tells me that x minus 3 is less than or equal to 0, which actually means I need to choose the negative sign. So as x is less than or equal to 3, we pick the negative sign. That's a little awkward, that's unusual. So that's saying that x, I'll add that extra line, x minus 3 is the negative square root. Really subtle, really unpleasant for the end of the paper. Finally, x equals 3 minus root 14 minus y. Remember why we did that? We did that to write down the inverse function. To write down the inverse function, we swap the x and y and we rename. So my inverse function, and I didn't rename, is as so. Okay, well the question asks us to find the range of values for which this is negative. So we're trying to find f inverse of x is less than 0. Well, what does that mean? 3 minus root 14 minus x is less than 0. Let's move stuff around, remembering with inequalities. If you times or divide by negatives, bad things happen. So I'll move that over. Let's get rid of the square root. So that's 9 is less than 14 minus x. Let's move the x over. So x plus 9 is less than 14, so x is less than 5. And I've now just reread the question and realised it said where f inverse is positive, not negative. So let's change some signs. It might be as simple as just changing all these signs over, but I'm going to think carefully about it. F inverse is positive, so that thing is positive. So 3 is greater than. Squaring both sides is still greater than. Moving x over is still greater than. So x is greater than 5. And looking back to the original question, we also needed x to be less than or equal to 3. But how can x be less than or equal to 3 and x being greater than 5? Because that was a condition. Because we swapped x and y at this point. That condition is for the x in f of x, whereas this is a condition for the x in f inverse. So that's absolutely fine. A bit of a worry for a moment, but that is okay. X is greater than 5 is our final answer. The paper is complete. Please do send any questions about this my way. And otherwise, have a wonderful rest of your day. Take care and happy revising.